Good evening. Thank you, Adam. Welcome to the show, another Spring One. You know, I love this time of year. It's a chance for us, as a Spring Source team to step back and actually sort of think about, well, what have we done over the last few months, and put it all together and actually package it up and present it to you. And it's always that you step back and like, wow, we've done a lot. And we have got a lot of stuff to share with you and talk to you, about over these next few days. Have one really piece of good news for you. You may have seen earlier on in the agenda, I was down to do the keynote both tonight and tomorrow night. The good news is you don't have to listen to me twice. I'm just teeing things up this evening. We have a fantastic lineup of speakers coming up really soon, and I've got some things I'm really excited to share with you tomorrow night. So this is a great time of year. This is our biggest Spring One ever. Great to see your faces. I've already met lots of familiar faces, and I'm sure I'm going to meet some new ones as well. When we think about sort of where we've come from, and for those of you that have been to a number of Spring Ones, you've heard us talk about this. Spring has evolved from a common set of underlying principles and a strong core and foundation. And over the years that's grown. So Spring was always about, in the early days, deployment flexibility. When we started, that meant I could deploy to WebSphere, WebLogic, or Tomcat. Nowadays that also includes cloud platforms, be that Google App Engine, be it Cloud Foundry, be it Heroku, etc. Spring was always about being able to create excellent web applications. Nowadays that extends to sort of not just web apps and modern style REST APIs, etc., but also integration workloads, batch workloads, including things like Hadoop processing, and you'll hear more about that over the coming few days. Spring was always about flexible access to data. In the early days that meant a variety of approaches for accessing what was in your relational database. Nowadays, as we all know, that the data universe is expanding very rapidly, and it means sort of flexible approaches for accessing data across a whole range of different stores and approaches. So the world of Spring, continues to grow and address the new challenges that rise year after year, but at the same, there are these core unifying principles that hold it all together. And so tonight, really, we want to sort of share with you a story in three parts. In the beginning, we're going to talk about that unifying component model, almost teach you how to think Spring, how to understand the way that the Spring family knits together, and how to think about what's going on inside the parts of the Spring programming model. And then we're going to talk a little bit about the changes in data. You've seen that the volumes of data are rising. Data is getting much bigger than it used to be. There are increasing demands to process data nearer and nearer to real time, so we need to be very fast with what we're doing with our data. And in addition, of course, we want to be able to dynamically adapt and evolve. We need to be flexible. And so this evolves to this little sort of saying big, fast, flexible data. And we're going to have Mark Pollack come up and take us through some of that. And finally, we're going to look at, as another one of our principles, those of you who've been to the show over the years, we're strong believers in, productivity and doing everything that we can to make you as productive as possible. And we're going to show off, some of the very latest things, from the Grails team that are really pretty impressive in that arena. So it only remains for me now to introduce to the stage someone it's a great privilege and honor to be able to bring up, Juergen Hoeller. You have Juergen to thank for the suggestion that Spring become an open source project. And Juergen has probably personally invested more time, more hours, more dedication into the Spring framework and the spiritual leadership of it over the years than probably anybody else. So a great privilege to introduce to you, Juergen Hoeller.
It's a pleasure to be here again, although we're actually in Washington for the first time, so it's kind of a fresh experience anyway. Connecting to Adrian's introduction, there are no official statistics in terms of how much time anyone really spent. But yeah, over the years I did spend a lot of time on all things Spring. And the Spring programming model, obviously, is an ongoing topic, right? It's the one thing that connects everything we're doing, basically. The heart of the programming model hasn't really ever radically changed, but we have added new perspectives. The way that we are looking at the component model now, in 2012, in 2013, is quite different from the way that we looked at it like just a couple of years ago. That's actually a pretty old little triangle here. I'm sure some of you remember. We've used it, I'm sure, like in 2006 or so, right? So it's probably about 6 years old. This triangle really illustrated and still illustrates key elements of the Spring model. Obviously, that's dependency injection, that's aspect orientation, although we're not actually using that term very much anymore. If you noticed over the years, we've added basically higher level, more explicit ways of tapping into aspect-oriented functionality, and that's exactly what we're going to talk about right afterwards. So, dependency injection, aspect orientation, and portable service abstractions, which is a very general term for basically everything that Spring does to connect to underlying middleware, underlying server APIs, underlying systems of any kind, also distribution and deployment arrangements. So that's really the good old Spring triangle. However, these days, I would actually use a slightly different perspective. From a modern day component model perspective, we are really dancing around annotated components, right? We basically have a strongly arranged, strongly, highly connected annotated component model these days, where many parts of the framework really come together in the form of a distinctive annotation-based style. This annotated component model obviously uses key framework functionality that's been there for a number of years. And, well, we have injection annotations, right? Dependency injection, the annotation way, that's injection annotations. We have composable stereotypes. That's kind of a new arrangement that we introduced back in the 2.5 days and strongly focused on in Spring 3.0. Composable stereotypes really is a key element of annotated components, and we'll get back to that in a moment. And in terms of service access, access to middleware functionality, access to everything from transactions to scheduling to declarative validation, etc., we have service-oriented annotations. That's basically a kind of summarizing term for plenty of annotations that we have that allow you to declaratively tap into some runtime service. And there are many of those. The core framework comes with quite a few, and obviously the wider Spring arrangement adds a lot to that picture. So in terms of annotated components, looking at source code, we're really just talking about three different things here. We're talking about a stereotype at the very top of a class. And I'd like to dive into this a little, because we use annotations in a very specific way. We're not just using them to kick off some framework service, some framework functionality based on an annotation. We're actually carefully designing our set of annotations. Stereotypes, for example, it's a service stereotype, but it's really a whole stereotype model. It has a basic add component stereotype, it has add service, it has add controller, add repository, add controller, in particular for Spring MVC controllers. So those stereotypes really describe what kind of class we're talking about. What is this? Basically, it isn't just a Java class. It's a specific kind of class. So basically, in a good old tradition of describing, annotating specific elements of the source code, we're basically adding not only to the runtime understanding of that component class, but also to the source code. Basically, we're adding to the readability of your source code. Those annotations and stereotypes are a good example. They really tell you something about that class, something important. usually in a concise and very descriptive form. That's why a stereotype is a noun, right? It basically says this class is a service class, is a repository class. Injection annotations, on the other hand, add AutoWired here. We obviously have add inject as well as the JSR 330 equivalent of add AutoWired. Injection annotations are kind of describing an injection need. They're basically saying this constructor is supposed to be AutoWired, needs to be AutoWired. You see how the wording flows? The whole point of injection annotations, of course, at runtime is for the framework to identify where to apply its dependency injection services. But if you look at it from a source code readability perspective, it really tells you something about that class, about the configuration perspective of that class, about the configuration needs, the configuration assumptions of that class. Our third kind, transaction annotations, and transactional down here, is another good example where we're basically saying something about the method that we're annotating. This method is transactional. Of course, that has a specific meaning at runtime. We'll kick off a transaction before we invoke the method, and we'll finish the transaction by committing it or rolling it back at the end of the invocation. But from a source code perspective, we're literally annotating this method. The method is transactional. And there's a good reason why we use an adjective there. It's transactional, a transactional method. So just to dive a little bit more into those three elements that I find particularly central to the modern day Spring Component model. Let's go back to stereotypes quickly. Stereotypes are actually composable. And I'm sure some of you are aware of this arrangement. I'm also pretty sure that not too many of you are actually fully using the potential, fully getting into the stereotype arrangement of building custom stereotypes of your own, with those stereotypes having a name of their own, a name that has a meaning in your architecture. I mean, in all fairness, at my service isn't a particularly meaningful name, right, in anyone's architecture. But imagine it could be an order service, an account service, a module of your choice service. The ability to put your own name, a custom name, onto those annotations is a pretty important feature in its own right. Of course, in terms of functionality, those stereotype annotations can be composed through meta annotations. So what we do here is basically we build our own annotation, the My Service annotation, and we meta annotate it with all the capabilities that it is supposed to combine. It has all the characteristics of a standard service. It uses a default scope request. It can use default transaction semantics. Basically, every time you're using at my service on any specific component class of yours, what you're basically saying is all of those semantics, all of those characteristics combined, one little annotation, and meaningfully named usually, hopefully in practice, combines all those characteristics. So any such class, any at my service annotated class has transactions on all its methods by default, default scope request, all service characteristics. Injection annotations, well, are probably the best known part, right? The part that is well understood, has been around for a while. Not only Spring's own add AutoWired, also JSR 330's add inject that we're supporting since Spring 3.0. They're pretty common. They're very commonly used these days. There are still capabilities lurking in there that are certainly not as much, well, not as well understood as they should be, not as well known simply as they should be. Some of those features, of course, are also pretty specific for pretty specific arrangements, pretty specific use cases. So in some cases, you could argue those features are basically only needed in the 10% case. Qualifiers, for example, our experiences show that in most cases there are other ways of uniquely identifying your components, so that qualifiers are kind of more of an extra bonus feature and not so central. Whereas, well, in the AdInject world, we also have a qualifier model. We also have provider, for example, the provider mechanism for lazily getting access, lazily retrieving an instance. There are quite a few features in the dependency injection corner, in the injection annotation corner, that are worth discovering or rediscovering in modern day Spring. In our third category, service-oriented annotations, where we basically declaratively declare a need for a specific service to be applied to the component, we have the transaction annotations, obviously. There are quite a few other ones. I'm just picking one here. Scheduling, cron-based triggering of a method. Basically, that's all that's needed. Well, there's a little bit of configuration. There needs to be a task scheduler with a specific thread pool setup once per application. Then all such annotated methods, all add-scheduled methods will be discovered and automatically invoked every time the trigger fires. So we're taking those ideas, we're taking this distinctive style quite far these days. And I'm only really showing a few selected features here. As a more recent example, in the declarative service category, let's look at caching quickly. And caching is another good example in terms of how we actually design those annotations. Look at this annotation here. It's called addCacheable because this method is cacheable. Well, what does this mean? It means this method basically could benefit from caching. It doesn't require caching. Those methods are usually fully functional without caching. It's a runtime concern, a configuration concern, whether caching is active and what kind and what degree of caching is active. Those annotations really basically tell you something about the method, about the need, the capability of that method. It's not a service requirement in the sense of I need caching, otherwise I'm going to break. That's why it's called addCacheable, and not like addCache attribute or addCache required or something. Of course, cacheable comes with a couple of variants. Conditions in terms of when to apply specific service, a kind of need declared, an ideal caching arrangement declared. Sort of that's where caching makes most sense. Please, if you apply caching, only apply it to that condition. That's what we're saying here. And well, with cache evict, that's kind of the other side of the corner. In some cases, for the lack of a purely descriptive name, we also have instruction-like annotations that basically kick off a specific event when the method is being triggered, right? So it's a specific design perspective that we're taking here. We're trying to carefully name those annotations as far as we can. And in some cases it works really well in terms of readability, in terms of just looking at the source code, finding out some characteristics of your own source code arrangement by just reading those annotations. All right, quickly looking at Spring MVC here. In Spring MVC land, we introduced a model that's being dubbed @MVC. It's not actually the official name. It's basically an annotation-based controller model for Spring MVC, introduced back in the 2.5 days and refined in 3.0 and in 3.1 and in 3.2. It's actually one of the most actively developed parts of Spring these days. And you'll learn about it at this conference. There are quite a few sessions that are Spring MVC related. So definitely check out those. There's a lot happening in that corner. But for the purposes of today, let's just look at the style here. We have a controller with handler methods. Those handler methods are being bound to specific paths. They're being mapped to specific request paths. That's what we're seeing here. At request mapping, it is metadata, but it is being associated with a specific method, discovered at runtime, and automatically interpreted by dispatcher servlet, which essentially makes sure that those mappings are actually applied. Another specific element of our design shows up here as well. It did actually show up before, for those who carefully looked. Parameter level annotations. We see a parameter level annotation applied to our long ID parameter here. Parameter level annotations are a standard Java 5 annotation feature, right? They are not particularly well known. Not many frameworks use them. Hardly anyone really is fully familiar with them. They're incredibly useful, though, for just associating specific metadata with a specific parameter. And thinking about the design here, we see a single parameter here. But the model, the controller model, actually allows for any number of parameters. Of course, if you have several parameters, the metadata really needs to be associated with a specific parameter. And add path variable here really describes what this specific long ID here means. It is supposed to be derived from a path variable, which means an incoming path is being mapped to the path specified in the request mapping annotation with the ID part, the variable part, extracted, automatically converted, and passed into the method. We are also using this arrangement for qualifying annotations. That's where we've been seeing it before, or for add value expressions, for example, all of which can be associated with a specific parameter. We go even further with our design by basically using a very similar style, very similar ideas for domain objects these days. So what Spring primarily manages, that's a kind of more service component model where, we find services, repositories, controllers, and so forth. However, Spring has quite a few services and quite a bit of component style for domain objects. And declarative validation, even if it comes from a standard GSR303 bin validation arrangement, is a good example. And it's actually something we've been waiting for. We wanted to have an annotation-based validation model for so long and didn't want to do it in Spring style only because it's so deep in your domain model, in the heart of your domain model. There really should be reusable standard annotations there that can be understood by many frameworks that are being used in combination. Think about a persistence framework, a component-oriented web framework, and Spring as the central orchestrator. All of those should really understand constraint annotations, and that's what we're seeing here. We're basically annotating a specific field in a domain object with constraints. Those constraints coming from the javax.validation package and telling you something about that field. Right? Those annotations really, in this case very obviously, add something to the meaning of that field. Because a date, a Java util date, is kind of a strange value type anyway, right? It could mean so many things. Is that supposed to be a date plus time, just a timestamp? Is it supposed to be a date in the past? Is it supposed to be a date in the future? Can it be null or not, right? There are so many questions, some of which can be answered through the use of annotations, constraint annotations in this case. Little side story. There are some things we can't do about such an arrangement, right? If there is Java util date and all the frameworks, the persistence arrangements, the web frameworks, they want Java util date, then it's really highly desirable for more specific types to be around. but it's not really Spring's job to provide them. That's why we are adopting JODA-time. We've been adopting JODA-time for a while. So this example, you could actually use a JODA-time local date or local time type there. And we are eagerly waiting for JSR 3.10 for the date and time APIs, the date and time value types in Java 8. Those would really add very nicely to this model, to this perspective of ours. All right, back to the main line. We see a Spring MVC handler method and an add valid annotation on our book parameter here. This really triggers a declarative validation step. And Spring basically orchestrates the process. If a request comes in, parameters are being bound, and before we invoke the method, we trigger validation steps on all add valid annotated objects. The actual validation is then performed by a JSR 303 provider at runtime. So it's a good example for the interaction between Spring's component model, Spring's component perspective, and standard elements like JSR 303 bean validation, which naturally integrate into Spring's unified component model here. To add a little bit to that domain model validation perspective, let's quickly talk about declarative formatting. Declarative formatting is a Spring feature, right? We're talking about Spring's datetime format annotation. But those annotations really sit very nicely next to the JSR 303 constraint annotations. This field here is supposed to be not null, it's supposed to be a date in the past. And if being bound from a string or rendered out to a string, there's a specific format suggestion associated with that field in the form of a datetime format here. So this is a Spring-specific feature that basically complements a standard feature, JSR 303 bean validation, just to add basically to a really nice overall experience. Designing your domain models using annotations, standard annotations, as well as possibly Spring annotations next to each other, and being just very readable, intuitively understandable, looking at the source code. And not always worrying about what those mean at runtime. They have runtime implications. They are being understood by frameworks, in this case even by a bean validation provider and by Spring. You don't need to worry about this. The whole point of us embracing different kinds of annotations into a unified model is to have basically a nicer experience on your side. A nicer experience when reading your source code, a nicer experience when the runtime implications of those annotations come together. All right, to wrap up towards, well, a more practical end here. Aside from the design, of course, we have a couple of, from the component model design, we have a couple of really nice pieces in place that just allow you to design an architecture around the Spring component model. To basically have a nice deployment arrangement, bootstrapping, specific kinds of components. We have plenty of features in place that allow you to selectively combine components from different sources. We allow you to explicitly define components. We allow you to scan the class path for components. We allow you to programmatically build an application context from components. That's a perspective that's actually not as well known as it maybe should. Using an annotation config application context, you can just basically say new annotation config application context, register class, 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 class. It's a var args method. Or combine it with the scanning of specific packages. A little note here that I'd like to just extract for a moment. The JPA arrangement, JPA entity classes. That's actually, again, something that quite naturally integrates with the Spring perspective. In JPA, you have entity classes. You're annotating them with @entity. You add metadata to the field and so forth, right? Just what JPA is supposed to achieve. But design-wise, It's quite similar to Spring. It uses a stereotype in identity, a required stereotype, just like Spring kind of requires stereotypes. We don't actually technically require them, we just strongly suggest them, but in JPA is a nice fit here. JPA performs a similar kind of scanning for similar kinds of components. Design-wise and readability-wise, they really add very nicely to Spring's unified component perspective. Quickly picking a specific feature from recent Spring 3.1 in this case, that I'm pretty sure that's not as well known as it should either. We were talking about the building of an annotation config application context, programmatic construction of your application architecture, basically, of the Spring elements of your application's architecture. We have a new mechanism called WebApplicationInitializer. That's a good example for what I'm talking about here as well, because a web application initializer is an interface building on a Servlet 3.0 mechanism, specifically the scanning of Servlet container initializers, as they are called in Servlet 3.0 land, and the registration of Servlet components against a given Servlet context. A pretty important new feature in Servlet 3.0 is the programmatic building of your Servlet context. And as shown in this example here, you can basically build, programmatically instantiate, like a Spring application context, register it with the Servlet context. An annotation config application context can just be instructed, instantiated, instructed to scan specific packages, then passed into a context loader listener, registered with the Servlet context add listener method. Those pieces really fall together very nicely. What we see here is a Servlet 3.0 foundational mechanism combined with a Spring detection arrangement, that's the web application initializer part. They are being auto-detected in your WebInflip, WebInfo classes directories. And the interaction between Spring APIs, Spring elements, like annotation config application context, and Servlet 3.0 elements, like Servlet context and Servlet context add listener and so forth. Of course, you can also register your dispatcher servlets, all your filters, everything you want in the form of web application initializers. Practically speaking, if you're consistently going with this style here, you won't have any web XML, not a single line of web XML anymore. So there are very practical implications here as well. Many of those Spring features, those more recent Spring component model features, also practically add to an XML-free configuration experience. And a key element of this experience, that's certainly a configuration class, the notion of configuration classes. And I'm sure most of you have seen configuration classes before, so we won't dive into the details. However, thinking about the combination of those features, Servlet 3.0 based web application initializers, building an annotation config application context, registering configuration classes with those application contexts. Those configuration classes themselves programmatically defining the central elements of your architecture, your applications, Spring beans, your applications components that are being managed by Spring. All of those things combined turn into a richer and richer experience. From Spring 3.0 to 3.1 to 3.2, we really completed this picture to a degree where it's a very seamless overall configuration experience if you want, without a single line of XML. And without a single line of XML here, can also be illustrated by this little variation of a configuration class, something you may not have seen before. In Spring 3.1, our JPA setup, local container entity manager factory bean, allows you to specify packages to scan, building what we call a default persistence unit. Indeed, this means there is no persistence XML. if you're using this style of configuration, you're building JPA persistence units without persistence XML having to sit around in some meta-inf directory. The ironic part of digging into XML-free configuration these days is that many standard elements of the Java stack, including JPA, mandate the use of XML configuration files. And we're actually trying very hard to improve on that experience. This is a non-standard feature applied to Spring's JPA setup. So in the meantime, Server 3.0 based, web application initializers, Spring configuration classes, annotation config application context, our packages to scan feature on our JPA setup. In combination, you can build a web applications configuration without web XML, without persistence XML, without any Spring XML involved. The reason why I'm reiterating on this notion is taking Spring's modern day annotation-based component model this model is a really rich arrangement in its own right. It can be defined, can be used, can be read, can be understood completely outside of the traditional XML configuration world. Of course, it may interact wherever you want it to interact with XML-based configuration. But it can also be used in a completely independent, distinctive form in its own right. So in this bit of time that we are having here today, I picked a couple of central elements to modern day Spring, to the modern day Spring component model. And just showing you how those pieces connect together, how they are designed, what kind of style we are using, how they interact with each other, not necessarily at runtime, but conceptually when reading your source code, and just what kind of configuration experience they can really add up to when being combined on a modern stack. Take Tomcat 7, Spring 3.1. This configuration experience that we're outlining here can be taken quite far on that kind of arrangement. And in terms of the central elements of our component model here, we have a view that we discussed in more detail: stereotypes, injection annotations, service-oriented annotations, and we've also been diving into the notion of using annotations in your domain model, of course. So there are quite a few different perspectives to take, just adding to the overall picture here. All right, so much for this story. That's a very core component model perspective. Next up, we're diving into the data world, where Mark Pollack is going to show, well, a couple of recent developments in the repository world. Mark, you're welcome to join me on stage. Here you go.
Thank you, sir. Which one's forward? Okay. Thank you very much. It's always a pleasure to be here. It's friendly faces, as Adrian was saying, and I hope to meet a lot of new people this time as well. What I'd like to talk to you about today is the Spring Data Project. It's a quite large project, but it has a central mission. The mission is to take up on the themes that Juergen has mentioned and provide a consistent and familiar Spring-based programming model that spans the range of needs that you now have with writing data-focused Java applications. So relational database support is there as always and improved, but we've also added significant support around NoSQL and big data. And when you look at what we'll have in the coming slides, you'll see a lot of familiarity with what you already know, so you can take your existing knowledge and extend it into this new area. So there's been a lot of changes in the data universe. There's a study from EMC every year, and they produce something called the Digital Universe Survey. And these are some interesting statistics from that survey, namely that the growth of data is incredible. Right now, 2010, there's essentially about 1,200 exabytes of data floating around the Earth, and is projected to increase sixfold by the year 2015. Similarly, the cost of managing and storing this data is dropping by a factor of 1/6. So we have more data than ever, and our ability to buy hardware to process that data is shrinking very rapidly. Enterprises really are using and storing more and more data in order to gain competitive advantage. So if you look at across different sectors in the U.S. industry, again, this is from the same survey, you'll find that 15 out of 17 sectors in the U.S. are storing more data than there is in the Library of Congress, which is around 300 terabytes of data. There are several companies that have more than 1 petabyte of data, which are actively mining and using. And the first people to really latch on to this need to process data at a bigger scale are companies like Amazon and Google with their Dynamo and Bigtable technologies, and as well as Google producing things as MapReduce and Google File System that reflect the open source efforts in the Hadoop ecosystem. Similarly, the structure of the data is no longer only relational. There's a wide range of new ways that data needs to be stored that defy the relational model. So these are things we've been used to, key value stores, but the scale now is usually much larger. Column-oriented stores, which are essentially the big table idea, where you have now values for your keys that also have rich structure and can scale to have billions of rows. Document-oriented data stores, in particular JSON document-oriented data stores, are also quite important and flexible, so you don't have as much impedance mismatch as you might have in a CMS system mapping onto a relational database as you would storing data inside of the document-oriented database. And also, for very complex relationships between different entities, you can now manage your data inside of a graph database. And all of these come to play in sort of a modern data access solution, and you can now pick and choose amongst these various technologies to find the best fit that's appropriate for your app, all the while keeping relational databases there as a mainstay solution and part of the enterprise. So storing the data is sort of one half of the equation. Actually, it's sort of maybe the easiest half. Me not being in operations, I guess I can say that. But getting the data isn't really useful unless you actually do something with it. And companies are, of course, driven by the bottom line. And what they're realizing is that by now collecting data that otherwise would sort of spill on the floor, such as data from cash registers, people even milling about in stores where they are, they can improve basically their bottom line. So as one sort of example, U.S. retail is expected to have a 60% increase in their margins, potentially, by adopting these new technologies and figuring out more and more how to better serve their customers. Similarly, it's sort of rejuvenated the whole field of data science, namely how do you look at all of this data and make sense of it. And this is a key aspect to it, even though it's very impressive to talk about how many, how big your disk drive is and stuff like that in your data center. Without this, sort of, it's really not very useful and to the enterprise. And so what we've done in Spring Data is we've taken a look at the entire landscape and started to chop away at different data assets technologies and provide a framework such that you can access them in a familiar pattern. So whether you're starting from Spring, which is probably most people in this audience, and moving to use new data technologies, that's one path. But also, historically, many people encountered the Spring framework because they fell in love with something like JDBC template. And they found it as a very useful class library, and then later went on to use things like dependency injection and AOP. And in a similar way, you could be starting from the left-hand side here and just using some small helper libraries, Mongo template, Neo4j template, all of these helper classes in the spirit of JDBC template, and get productivity in your application development. So the themes that we aim for are consistency, namely in the spirit that Juergen mentioned. We name things appropriately. We take care in doing that to make sure there's a consistent carryover from the base framework to the data frameworks. Accuracy, in particular early on, we've chosen not to follow the annotation model in JPA for mapping objects into data stores. It's not a good fit. Some people take this approach, but we've chosen a different approach, which we'll see in a second, that keeps a programming model familiarity, but not down to the levels of the exact individual annotations that are used. Productivity has also been a hallmark of Spring Framework, and we continue that by providing various template classes to help you access all of these technologies. Object mapping for object stores that are queryable, and as well as this repository support, which I'll show you in a moment, that makes it really very, very simple to have a data access layer up and running, very feature-rich with very little coding on your part. And one part to me that's very exciting right now is what I would call horizontal integration. There's enough of a base outside of the core Spring Framework that we can start to combine these projects together to create really powerful solutions. So in particular, combining Spring Security, Spring Batch, Spring Integration, all of these together in a data-centric application enable you to really have a platform for creating data-focused solutions. These are some brief statistics of sort of how busy we've been this year. I just took a tally on the train ride over here. There have been over 60 releases in the Spring Data family of projects in the past year since the last Spring 1. It's a pretty impressive number. Today we announced the release train for Spring Data. This includes pretty much all of our components at a GA level, some still at RC level like Spring Hadoop and the JDBC extensions. But it's quite a mature set of projects, and we're now in our third year basically of iterating on this theme. And last but not least, the Spring Data team wrote a book, an O'Reilly book, which you can pick up for free by going to the O'Reilly website and entering the code that's on the back of your handout when you registered during the length of this conference. And in it, you'll find a really wide range of topics that you can use and extensive sample applications hosted on GitHub to help get you started. So drilling into the configuration model to show you an example, on one side we have JPA, on the other side we have Mongo, to show you the similarity in the theme of the programming model that Spring provides, and also to highlight where there are some differences that are appropriate for the different technologies that are being used. Here we have the @configuration class, where we're going to enable component scanning with the @component scan annotation, as well as enable transaction management. And in particular, for the Spring Data repository support, we enable the scanning of repository annotations through an enable JPA repositories annotation. And then we have, as normal, if you're configuring a JPA provider, the data source, the platform transaction manager, and I didn't put the long class name there that Juergen had for scanning of persistent entities. Suddenly on the right-hand side, we have a configuration class, this time for MongoDB. The central element here isn't a data source, but it's creating a Mongo instance and its database name. But it shares a similar theme of @configuration annotations. Here we move on to object mapping. This is quite familiar, of course, in the JPA case where we have entity and table annotations. And we've chosen to use instead a document annotation to better express the fact that we're persisting this as a document. In particular, any specific values that we need to put on the document annotation, we will to further not shoehorn it into an existing model that was never intended for a non-relational data store. Many-to-one annotation really has an analog in MongoDB as a dbref. And similarly, containment of nested classes in a document database is sort of a natural thing. There's no need to really have any extra information on the class to say that the line items of this order need to be associated with the order. And here we see the repository support we have. Tomorrow there'll be a session on this in more detail. But this provides the functionality of you writing just an interface and extending some Spring Data interfaces to get basic CRUD, and also, in this case, I'm showing the use of Query DSL, which is a type-safe querying language, to, in this case, do create, update, delete on products. And what's similar in this case, the top is JPA, the bottom is a Mongo-based repository, is the interface declaration is identical, and the finders that we defined are finders by convention, so find by description containing. Those are similar. We have paging support in both of them. But then you can kind of go under the covers and say, I would like to query using the native JPA QL, or I'd like to query using Mongo's query language. And we can override how to infer the query from the method name by providing a query annotation that's specific to the technology at hand. So it shows you that there's a lot of similarity. There's a theme that where you need to get specific, you still can. And we don't intend to abstract away to a common denominator the way you access all of these rich data access stores, data stores. So what I'd like to show now is a demo app that I built that shows the horizontal integration, namely it uses together a bunch of the Spring projects, notably Spring Integration and Spring Batch. And what's important here is that as I've observed people implementing big data solutions, it actually fundamentally is an integration problem. There are a variety of steps that you have to take. You have to collect all of the data. It has to be transformed. As the data is coming in, it's very common to do analysis on that stream as the data comes in, because it's quite likely you won't be able to get access to that data until hours or days later as it's ingested and put into a large data store such as Hadoop. And then once it's in a system such as Hadoop, Hadoop is fundamentally a batch-oriented system. And so we've made extensions to Spring Batch under the name Spring Hadoop that makes it much easier for you to analyze data in Hadoop. And last but not least, you have to distribute this data out of the batch system onto a local file system, or, for example, into other data stores that you can do more traditional business intelligence or data mining on. And the example what I'll show you is I've taken the Twitter search feature as well as the garden hose, which is a continuous real-time stream, about a few % of the Twitter stream, and consume this inside of a Spring integration application, update some real-time statistics in Redis, and at the same time write that data into Splunk and Hadoop. And then there's a web app that is running a batch job to extract historical data out of Hadoop as well as display data that was accumulated in Redis. Let me switch now to this guy. So this has been chumming along for quite a while, actually. It's been up here for several hours, and I've been collecting data for a few days off of Twitter. So here we see Spring. Oh, do we see? We don't see. You see it up there? Ah, there we go. Lovely. Spring integration application. It's using the Spring integration support for doing a Twitter search. And since we're in DC, I thought it'd be fun to see who's more popular, Obama, Romney, or Justin Bieber. This came up out of Mark Fisher's discovery when we were developing the early versions of this app that Justin Bieber appears in an awfully unusually large number of tweets. So we chain this search into Hadoop. I do some counting, and then, oh, here it is, and then also send this data off into Splunk. And this part here is the Redis counting. Okay, so here you see the console app, and you might see a lot of dirty words. There's an awful lot of cursing going on Twitter. And this is Twitter search. It's actually not a very high input stream, so you really don't necessarily need to store it in HDFS, but that's what I did for this case to be uniform. So you might see a tick mark here and there. This is collecting stats inside of Redis. Here's the console for Redis. So if you look at, for example, the total of tweets today, 10:15, for Obama, you see it's 542. Oops. For Romney, 140. And anyone want to guess where our friend Bieber is? Or where is it? I don't want to type it. There we go. Ooh, 553, just beating out Obama. Normally, Bieber kills Obama. It's amazing. And there's subsets of this that you can store, for example, for 2 o'clock today, inside of a Redis hash, I store the counts per minute. So even though this is not particularly printed very well, you see for the 0th minute there was 1 count, 4th minute there was 11. So you can build out your whole timeline of counts here. And Redis is very good at doing these type of counting activities. So as I said, the data gets stored inside of HDFS. Here is sort of that log. So we're at 49. If I browse this again, 49, it's, now I'm up to 61. Oop, it's writing that one right now. So there are the tweets. And then Gunnar Hillard was nice enough to write a nice application here to show visualization of the search data. So you can see Obama's in blue, Romney in red, and Bieber's in yellow. And usually Bieber's quite popular. Here's the running tally of today's votes. And then I look in the Redis hash to look at sort of a little bit of a timeline to see how many in the last hour, the last 3 hours, and the last 6 hours, and so on. Similarly, oops, you can show this information inside of Splunk. So I could go back here. Just run that again. So there we go. I'm looking for all the source is Twitter. I'm looking for tags that have those regular expressions, and then I just graph them quickly. And here you can see a similar graph. You could sort of play around. This is all time. If you look at the last 4 hours, so I've stopped collecting data in this for a while. You see it's fairly sparse, but it's nice to explore the space. And last thing I'll show you is collecting from the Twitter garden hose. So I'll start up Spring integration application that does that. And this is a lot of data, so I don't keep it running in the background. As you can see, it's kind of pouring in there right now. And if you go back to our friendly little app here, go to the garden hose. This is the most recently popular tags. This will change in a moment. High school made me realize. That's a very good coffee conversation, beer conversation. Girls like it when you ... But, it's not all bad and gossipy. If you look at what I recorded in the garden hose last Friday for the vice presidential debate, see there's some consciousness on Twitter about politics as well. So this guy should be updating a little bit. I don't see him updating. Oops. Let's see. So here's the raw stream. I set it rather low just to see it accumulate. So 34, hopefully it's 35, and so on. So if we switch back to the other monitor, yep. And there's one last little tidbit. This is Neo4j analysis of the tweets. So what you can do here is you can say who tweeted what, who did they mention, and also how many times did they refer to the tag, and all sorts of little graphs you can build up with this. And also Michael Hunger, who was nice enough to make this, had a hard time finding a clean version of a tweet. So that was a quick tour through a little app. I hope you found it as entertaining as I did writing it. And now what I'd like to do is hand it over to Graeme, who will talk about all the great things that's going on in the Groovy and Grails community.
Thanks a lot. Thanks a lot. It's great to be back here again for another SpringOne2GX, and after all that awesome news from the Spring data team and from Juergen, it's time to talk about a bit of Groovy and Grail stuff. So moving ahead, just in terms of a brief status update, we have had a pretty big year in terms of Groovy and Grail's tech. Grails has had nine releases this year so far. We started off with the 2.0 line, released 2.1, and right now we're up to the 2.2 release candidate stage, so we're making some good progress there. And Grails 2.3 is currently in progress at the moment, so that's the currently in development version. And then on the Groovy side of things, Groovy had its big 2.0 release, a fantastic milestone for Groovy. Brought some great features like static compilation, static type checking, and a whole load of improvements to the runtime in terms of invoke dynamic support. So really great things coming on, for Groovy as well. Looking further ahead, with Grails 2.3, we have a strong focus on RESTful services, on data binding, on improving our support for encoding and escaping, Hibernate 4 support. Then on the Groovy side, there's even more focus on invoke dynamic. The Java virtual machine and the JVM in JDK 7 and in upcoming JDK 8 is really improving dramatically in terms of what it's capable of with invoke dynamic. And the Groovy team on top of things in terms of taking advantage of those. Also in Groovy 2.1, we're looking at improving the type checking even further to allow type checking of certain types of DSLs. The Groovy team are really strongly invested in improving that feature and making it more usable for cases where Groovy is really popular in creating DSLs. So, also in terms of compiler plugins, so really making it possible for developers to extend the compilation and static compilation process through compiler plugins. And now the news, we have a new website for Grails coming up, approaching readiness. It's currently available at beta.grails.org. It's really been a great achievement through the Grails community because the Grails website is completely open source. It's available on GitHub. You can check it out. It's an example project. It's been rewritten from the ground up on Grails 2.1 with jQuery, resources, all the latest kind of tech from the plugin community. And we've taken numerous contributions from the community. It's really an interesting way to get involved and contribute to the Grails community by contributing to the website. And it's an important infrastructural piece for Grails because the website obviously is the face of the plugin portal, and with plugins becoming such a key part of the Grails framework, worth getting involved if you fancy a bite at getting involved with the community. And in the last year, there's been even more companies adopting Grails. From trendy names like Netflix, the Netflix guys using Grails, well-known broadcasters like Sky News, to more conservative enterprises like Nationwide Insurance and a French insurance company called MACSF, and big retailers in the US like Big Lots. So many more companies adopting Grails, and Grails usage continuing to grow. So good year for Grails in general. But now I'm going to talk about Grails and these new application architectures that were being mentioned before in terms of data, but also in terms of the way you structure your applications around stateful and RESTful web services. So Grails is already being used with these modern JavaScript MVC frameworks where you typically have a stateful, RESTful backend, and you combine it with a JavaScript MVC, either Backbone or Knockout or Angular. And we've really been moving Grails more to support that model. Obviously, we'll always support the more traditional model of request response and rendering GSPs, but with this trend of having more RESTful backends, more JavaScript handling of the view rendering, and more the involvement of JavaScript MVCs, that's why with Grails 2.3 we've placed a huge focus on improving the RESTful services and the creation of RESTful services with Grails applications. In addition, we will also be looking at really how we can improve async programming models with Grails coming up in the future. And one project that is really kicking that off is a plugin for Grails from the core team called Platform Core. It has an eventing model in it. And it's really going to be the framework for the new eventing model within Grails. And it plugs into things like Spring integration and WebSockets and so forth. And I'll be doing a brief demo now to demonstrate to you how easy it is to actually build these kind of modern applications with Grails. And it's such a simple demo, I'm sure there's no chance it could possibly go wrong. So, famous last words. We'll see. So if we switch over to this laptop now and try and get this demo going. Okay. So what I've got here is a very basic empty Grails application. And what I'm going to do is I'm going to create a domain class called to-do. There it is. Okay, so this is my domain class, very simple. And I'm going to give it a title. And if we want, we can apply some constraints. But before I continue, I'm just going to show you the build config of this application. So this application has several interesting plugins installed. One of them is the Angular scaffolding plugin. So this is a plugin for AngularJS that allows you to generate scaffolded interfaces using the AngularJS JavaScript MVC framework. The other interesting one is the Platform Core. So this is the new plugin that's under development, which, as I said, is really going to provide new foundational APIs for Grails going forward, specifically around eventing. Another third interesting plugin is a plugin called Events Push, which builds on top of Platform Core and basically provides propagation of Grails events to the browser. Other interesting plugins I have Twitter Bootstrap for UI formatting and MongoDB for persistence. Okay, so what I'm going to do now is run a script called ng-generate-all for my domain class. And this is going to generate the Angular scaffolding interfaces. There we go. And now we can run our application. Oops. Oh, that worked. Okay. As you can see, I've done this before. Okay, so here's my basic application. It currently doesn't look terribly impressive. What I'm going to do is open up the index.jsp and put a require in there on the Bootstrap module. So as I showed to you before, we have the Twitter Bootstrap plugin installed, and that provides a resources module for Bootstrap, which I can depend on, and that will automatically give me all of the necessary CSS and needed to use the Twitter Bootstrap library. Now if I refresh my page, we get a prettier looking Twitter Bootstrap enhanced UI. But as you can see from the URL at the top here, if we look at the top, this is a single page app, so the URL itself is not changing. It's changing hashtags at the top there. And the whole application is built around this single page experience. Okay, so the next thing I'm going to do here is I'm going to just stop my app briefly, and I'm going to create a file under the conf directory called to-do-events.groovy. And what I'm going to put in here is I'm going to put an events definition, which I'm basically going to listen to all after insert events. Every time a record is inserted in the GORM namespace for my to-do domain, I want to push that to the browser. This is what this browser true is saying. So basically what it's saying, every time a to-do is inserted, push that to the browser. Save that. Run my application again. And now if we go back to my index.jsp file, I'm going to require a second module. This one's going to be called Grails Events. So the Events Push plugin essentially provides a resources model called Grails Events, which provides some JavaScript to hook into the Grails eventing system from the browser. So I'm going to save that now. And the next thing I'm going to do is register this page to listen to events. So what I've basically done here is created a new Grails events object in my JavaScript definition here that's going to listen via WebSockets to every time a to-do is inserted, it's going to receive the WebSocket event and propagate it down to the browser. But of course I probably need to do something with that, so let me create a div here where basically I'm going to get h3 and this is going to basically list all recent to-dos. There we go. So now if we refresh my page, so down here we've got a little box down here called recent to-dos, and that's basically going to have a list of all to-dos that were added recently. And what I'm going to do up here is add an event listener. So on the after insert event, basically trigger this function. And what we're going to do is basically get hold of the title of the to-do, and using just some jQuery, we're going to append it to my list. Probably probably I should give it a... There we go. Okay, so now every time I add a new to-do, upgrade to Grails 2.1, it gets added down here. And if I open up a second browser, so we've got two browsers ongoing here. Upgrade to Groovy 2. There you go. Attend great sessions at 2GX. So as you can see, this is using persisting to MongoDB, all of these to-do items, and then asynchronously basically registering by WebSockets for new to-dos as they get inserted. And I'm listening to GORM events. So as you can see in my to-do events class here, I'm listening to the after insert event triggered from GORM, and it's basically getting pushed to the browser, and I can register that all pretty seamlessly. As you can see, this is a pretty simple application that I built here, but demonstrates a lot of complex technologies, ongoing modern technologies, single page apps, MongoDB, WebSockets. Easy. Okay, if we can switch back to the slides. So that was the demo. So in summary then, as I showed you there, that was actually using GORM for MongoDB. So GORM obviously is one of the killer features of Grails, the persistence technology, and GORM for MongoDB recently we released the 1.0 GA version of that. We also have in milestone form GORM for Neo4j, GORM for SimpleDB, DynamoDB, and JPA and various other persistence technologies in either milestone or release candidate form. What was also demonstrated there is we already provide strong support for building RESTful web services that can power single-page web apps built with things like AngularJS or Backbone or Knockout, but that we're really focused on improving that area. And another key thing that that demo demonstrates is the strength of the plugin ecosystem. So that I invoked a number of different plugins for Grails. I installed them and harnessed them to create a pretty complex application that out of the box you don't get with Grails, but just by combining a few plugins, we created a pretty powerful application pretty easily. And so with that, that is the end of that brief demo. I'm going to hand it over back to Adrian. Thank you very much for your attention, and make sure you check out all the cool Grails sessions.
Excellent. Thank you, Graeme. So we've been on quite a tour this evening. You've seen how from a set of sort of consistent and coherent principles, Spring has evolved over the years to really embrace all of the many modern demands and varied demands that are being placed upon applications that we're writing in 2012 and beyond. Spring from its very beginnings had some of those core principles baked in, but now they're applying to a whole wide range of varieties of sort of cloud application platforms, a variety of data, integration, batch, Hadoop, you name it. We really work really hard to keep Spring absolutely at the forefront of where enterprise development is at. I hope you enjoyed seeing sort of code on the slides within about the first 5 minutes of a keynote, because we're going to do plenty more of that again tomorrow. So that's kind of the Spring style, and it's got lots of great technical content for you coming up. We're done for tonight. I'm going to call that a wrap. But before we leave the stage, there is one last piece of entertainment I'm told to inform you about. I'm pretty much in the dark as to exactly what this entails, as is Adam, but we're looking forward to it, and I hope you enjoy it. So one more 10-minute little interlude, and then off to the reception. Thank you very much, and good night.